Okay, so we're looking at cylinders and cones today, specifically finding the volume of both of those. Volume is the measure of space occupied by a solid, and the way I like to think about it again is that we have lines that can make perimeters of things, and perimeters can form areas, and then if we have multiple areas, right, multiple sides, that can contain volume. The areas can contain volume. Okay. Specifically today we're going to look at a cylinder, which is actually the exact same formula as a prism. We'll look at cones briefly. Cones are related to cylinders, we'll put it that way. Okay, so volume equals capital B times capital H, right, which is the area of the base. So again, this is going to be very determined on circles because that's the shape of our bases, and then the height of the cylinder. Our area formulas on our formula sheet, right, are capital B. So here's the formula we're looking at. Volume equals area of the base times height. Then we're going to go to circle, right, and we change our formula sheet to represent, to show that capital B is the same thing as area, and it's pi r squared. So B is pi r squared, pi times the radius squared. And so our formula V equals BH, right, this one can really be rewritten as V equals pi r squared times the height. Okay. All right, so let's just do some examples now. We're given the radius here, so we don't need to do anything to it, and we're given the height, which is 12. These are meters. Okay, so those are two one-dimensional metrics. Volume equals capital B, or pi r squared times h. So we're going to write it that way. Volume equals pi, which is 3.14. I'm going to put it in parentheses. Pi r, which is 4, put it in parentheses, squared, times 12, times the height. Okay, and like I've said, throughout this unit, if you learn how to use a recipe, right, then you can cook anything, right? If you learn how to use a formula, you can do any of these math problems. It's just understanding how to put in numbers where they're supposed to go. So you understand where the radius is, you understand where the radius goes. You understand what the height is, the distance between the circles, distance between the bases, you understand where it goes. And I'll use our old school calculator today, but of course you can use Desmos for these. 3.14 times 4 squared times 12. 602.88, and I'm going to round that off to 602.9. Okay, meters cubed again, because this is saying there's 602.9 cubes that will fit, cubic meters that would fit. So literally it's like how many cubes fit inside the cylinder is the question we're answering, right? If they were all, stacked together with no space in between. And pieces of cubes, right, because we got 0.9. Questions? Okay, the next one. Does anyone see the difference between these two cylinders in terms of the information we're given? One's longer. Well, it's a longer measurement given, so is that the radius or the diameter? It's the diameter. So what do we need to do to the diameter? Half it, yeah. Half it's good. So what is half of 24, guys? 12, right? We half the diameter. Right? And then we've got the height, which is still the distance between the circles. In this case, is 15. Necesitas dividir para 2. ¿Sí? Porque es diámetro, necesitas el radio. Stop. Okay. Make a pass. Okay, so then we have our volume formula. Volume again equals BH. I'm going to go ahead and just write it as volume equals pi r squared h, and then we'll fill those in. Volume equals 3.14 times 12 squared times the height times 15. You know, for sake of time, if you have it typed into your calculator, you can kind of just go in and, you know, alter your previous problem. So I'm just going to make that a 12 and turn that into a 15. And we have our answer, 6,782.4. And I'm rounding everything to the tenths place, right? Because this one is, well, that's all the remainder given. But that's what we're going to remember it to, right? That's the attention we're going to give it. We're going to give it attention up to the tenths place. This is millimeters, cubic millimeters. Okay. Practice problem number 1. I'm going to give y'all a minute to go ahead and try to solve that. So you'll have your radius and your height given. See if y'all can figure that one out. It's take like 60 seconds. At least set up the formula. When you're at the radius, do you cube it or do you square it? Squaring, yeah. Your final result is going to be a cubed answer, but for this first part, when you're finding capital B, you're finding the area of the base, which is a two-dimensional thing, right? It's a flat. So you're finding the area of the circle. So, good question. You don't have to cube anything in any formula other than the sphere. Okay, the sphere's formula is the one that includes the radius cubed, and partly because that's the only variable used in a sphere's formula. So we have the radius, which was what? And then the height, 10, and then our same formula, volume equals, I'm going to write pi as 3.14. That's how you're going to write it on your homework assignments. Radius is 5. The exponent, the little number there, it doesn't necessarily need to be outside of the parentheses. I just like to put it there because I put my variables in parentheses. I treat parentheses kind of like slots that you know, put your missing numbers into. So that's it. This one's not too bad. 5 times 5, 5 squared is 25. 25 times 10 is 250. 250 times 3 would be like 750.
It was 778.5.
778.5. And that's there, not meters, inches. That's where you would have your cubic, because now we're talking volume when they're all multiplied together. A good example I gave a class yesterday is like if you have a book, right, or even just a thing of note cards. I think of volume like this. So you find the area by, okay, the area, it's 3 inches by 3 inches. So the area is you take right? Take the base and the height, or the length and the width, you multiply them together, you get 9 square inches. And so literally we have a square that has, 1, 2, 3, that has 9, 5, 6, 7, 8, 9 squares on it, right? So that's the area. Volume now, like if you think of a book, right, it's a bunch of areas like stacked together. So that's one way to kind of think about it, I don't know, as these like layers of a cake, right? And so how thick is the cake? How thick is the book, right? Well, not very thick in this case, but we're looking at not quite a 1/4 inch. Let's see, 1, 2. Yeah, we can call it a 1/4 inch. Might have been a little less, but a 1/4 inch. So then we multiply it by the height of the whatever we're multiplying, right? So it's multiply, multiply, multiply for a prism. Okay, so we're doing the same thing with a circle, right? We're finding the area of the circle and then how deep is it? What's the height of it? Okay. Here's another practice one. We're given, I'm going to go ahead and do this one with y'all. We're given a diameter, and so we need the radius to be 6 because we're going to half it. And then the height is 10.5 or 10.5. And so volume equals 3.14 times 6 squared times 10.5. I'm going to leave that for the calculator. 6 and 10.5. 1,186.9. And these volume numbers, they can get pretty big. Oh, cubed. What'd you say? Oh, is it? Can't see it. 1,186.9. And that's cubic miles. That'd be a big cylinder. Okay, flip the page. We'll do 3 more problems, and then we'll watch that video. So, a trough used for watering horses. Anybody ever kept horses or ridden horses? No, nobody. Well, like I have, I've raised goats, and so you have a water trough for them. What shape would you say that trough is? Kind of look closely at it. Like, how would you describe that? Yeah, so it's got a rectangle in it. What is the base, though? Remember, we named things by the base. What is the base of that shape? Half circle. Exactly. It's a half circle. Now, we don't have endless formulas for, well, this is if you have a half cylinder, you use this formula. If you have a 1/4 cylinder, you use this formula. We just take our formula. Yeah, make a pass. We just take our formula for cylinder, and then what are we going to do to it? We'll divide it by 2, right? Or we'll multiply it by a half. Again, that's the same thing. Multiplying by a half, dividing by 2, you get the same result. Okay? So, half of a cylinder. We've got a radius of 1 foot. That's a pretty, nice radius. It'll make the calculations easy. And a height of 15. And so you do the exact same thing. And this is a good example of what a test question might look like. You're going to have to know how to use a formula, but then you got to think a little bit on top of that. We got half a cylinder, so half the formula, right? Or half your answer, rather. So volume is still equal to pi 3.14 times the radius squared, so 1 squared times the height. Okay, 1 squared is, what is 1 times 1? 1, right? So that's nothing. And then, let me use this one because we already have the 15 typed in. Let's see, did we do all that right? Oh, I got a 6 in there somehow. Let's just start over there. Oh, I added it to the end. Okay, I'm just going to type this in again. 3.14 times 1 squared, which is 1, but I'll type it in just for good measure, times 15. 47.1. And are we done? No. Right, because again, this is half of the cylinder. So all we did is we found, if this was a full cylinder, but the piece of wood or metal before it was cut in half, right? There's the volume. Okay, but this is half a cylinder. So how much water does this trough hold? Well, it would be divided by 2 or multiply it by half. 23.55, so we'll call that 23.6. 23.6 cubic feet of water. Cubic feet of water. Okay, all right, nearly done. Last thing really to cover is, well, what if you know the volume, but you don't know the base? Or if you know the volume, but you don't know the height? So, working backwards, right? We have our formula, V equals BH, except for here we have V. So V is 3546.7. And we don't have B entirely, but we have R. We have R is 8.4. Okay, and if we spell out our formula a little more, it'd be 3.14, right, pi R squared, right? So 8.4 squared times the height. We have a one variable problem, and we know how to do one variable problems, right? So I'll remind y'all how to do this in Desmos. If you want to solve any equation in Desmos, you simply type in y equals twice, right? And then type in the left side of the equation, and then type in the right side of the equations. Where the lines cross on the graph is your answer, right? So you can do that in Desmos. Or if you want to do this by hand, which I will show now, 3.14 times 8.4 squared. I'll keep the remainder so we have a little more accuracy. And then times the height. So do all that right, yeah. Does anyone remember the opposite? How do you undo multiplication? You divide. Yeah, good. So, yeah, it just turns into a one-step equation, right? 2, 2, 1.5584 dividing. I think I got my math right, but you get the idea if I didn't. 3546.7 divided by 221.5584. So our answer, we're going to round that to 16. Okay, and that's our height. Let's put a height here. Right, our area of the base, yeah, that was 221. That was this number. I have to rewrite it. Thank you. Okay. All right, this is the last real problem on the page. It says Amy's Chili sells cans of chili that hold approximately 50 cubic inches. So anytime you see that cubic inches, that's a volume. So the volume is 50. We can put cubic inches next to it. And that's going to equal a base of a B, right, of 7.1, and then we're figuring out what the height is. And so this is a simple one-step opposite of multiplication and division. You can draw your line down the middle. That's good practice. 7.1, and we'll have our answer. Okay, so these backwards problems, however you want to call it, they're not, y'all can do these. 50 divided by 7.1. That's going to be a height of 7.0, right? We don't round up the 4 for that remainder. We'll just forget about it. Not worth remembering. Okay. Last question I have for y'all. I used to do a demonstration with this, maybe, but we won't worry about that today. Imagine this cone. You don't need to read anything. Just imagine this cone is full of water or Kool-Aid or something. I guess it's red. It's full of Kool-Aid. How many times do you pour this cone into this cup for it to be full? Twice? 1.5. Most people say twice. Like if I, didn't do this for 5 years, I would want to say twice just because that's what it looks like. Look at your formula sheet real quick. And it'll give you a hint. Look at the formula for volume of cone and the volume of a cylinder. What's the difference? What is our formula for the volume of a cone? Yeah, exactly. So, how many times do you think it? Yeah, no, you're at it. You got it. It's 3 times. Right? And so a cone of the same base, right, meaning the same radius and the same height. So same radius, this is the same measurement, this is the same measurement, right, is really 1/3 the size. So it takes 3 cone-shaped funnels to fill that up. Right? And that's just good, I'm going to show you all this, whenever y'all ask me for water, I give you one of these cups, right? Have you all had those, like a sport event or whatever, you get a Gatorade cup that's like a cone shaped, and you just fill it up? So just so y'all realize how much less fluid that is, just to kind of drive this point home, right? Here is, if it was a cone, those same cone, this is how much water you'd be drinking from this cup, like that much water. Right, if you're just using one of those little cone-shaped ones. That's why you whenever you do it, you stand there and you get some, get some, get some, get some. Right, because it's really not that much water in a cone. Probably why they have ice cream cones, right? It's a lot less ice cream they have to sell than if it was a cylinder shape. Okay, and that takes us to our next our video on how cans are produced. And I know this is not going to be everyone's cup of tea. It's a 10-minute long video, so you'll survive. But what I want you to focus on is the geometry, right, that goes into making an everyday object like a soda can. It's pretty amazing. And a lot of y'all ask me, when am I going to use such and such in real life or whatever, math, You may not use it, but one thing I want you to get from my class is that it's all around you, right? So even something like a can, right? It took decades, over a century of engineering and math to get what we have today, and it's pretty remarkable. So we'll watch this video, and then your assignment tonight is volume of cylinders and cones, which is